morning, everybody. I am Dr. S.S. Naidu, Assistant Professor in Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss very important topic in probability and statistics. That is, we are doing very important sums on normal distribution. Already we have discussed about normal distribution. Normal distribution comes under continuous probability, continuous random variable. So this binomial distribution and Poisson distribution, those two are probability distributions defined for discrete random variable, whereas normal distribution is defined for continuous random variable. And when a binomial distribution is defined for n is equal to n tends to infinity, it becomes a case of a normal distribution. So normal distribution is an indefatigable probability distribution, tenacious probability distribution, or pertinacious probability distribution. So it is a normal distribution is nothing but it is some persistent normal distribution. Means it is a continuous normal distribution. So in this normal distribution, it maintains a bell-shaped curve. It never touches horizontal line or simply x-axis. Why? Because it is a continuous random curve. A continuous probability distribution curve. It never touches x-axis or normal distribution. So in this normal distribution, suppose where it has mean 0 and standard deviation 1, then it is known as standard normal distribution. So standard normal distribution is a special case of normal distribution. So whenever mu is equal to 0, means mean is 0 and sigma, that is standard deviation, is 1, then we say it is a standard normal distribution. So this standard normal distribution, that probability oscillates by taking center at 0, because its mean is 0. That's why it vibrates from center at 0, and with the value of standard deviation, it moves it vibrates from that center. That is the significance of standard normal distribution. So this standard normal distribution or normal distribution, they maintain a bell-shaped curve. From that at that bell-shaped curve, we can imagine left-hand side curve, right-hand side curve. From left-hand side, how much area it has occupied. From right-hand side, how much area it has occupied. All these things we will discuss by analyzing its probability distribution. So this now let us discuss the standard normal distribution. So the standard normal distribution is one of the forms of the normal distribution. So it occurs when a normal random variable has a mean equal to 0 and a standard deviation equal to 1. So for a standard normal distribution, mu it is mean is equal to 0 and its standard deviation sigma is equal to 1. Then we say that normal distribution is a standard normal distribution. So in other words, a normal distribution with a mean 0 and a standard deviation of 1 is called the standard normal distribution. Also, the standard normal distribution is centered at 0 and at this value mu is there. From that with a sigma value, its probability vibrates. Also, the standard normal distribution, it is centered at 0, and the standard with the value of standard deviation, it gives the degree to which a given measurement deviates from its mean, like this. So it is a feature of standard normal distribution. So the random variable of a standard normal distribution is known as the standard score or a Z score. That Z score is defined as random variable minus mu by standard deviation sigma. Z is equal to x minus mu by sigma. That Z value is called Z score. Here, this value is very, very important, because in solving sums, we convert whatever probability distribution is there, that those x values, we convert them into Z values, Z scores. Then that table, that distribution automatically converts into the standard normal distribution. Then by seeing the tables from normal distribution tabular form, we will find values and substitute and simplify the answer. It will come very easily. So it is a very easier process than solving them in a continuous random variables. Here, x is a normal random variable, mu is the mean of x, and sigma is the standard deviation of x. So we can find the normal distribution here from this, and in probability theory also, the normal or Gaussian distribution is a very common continuous probability distribution. Here, normal distribution is also known as Gaussian distribution. Both are same. Normal distribution is also known as Gaussian distribution. So this normal distribution or Gaussian distribution, it is a case of continuous probability distribution. This normal distribution or Gaussian distribution is a special case of continuous probability distribution. So now let us analyze how to see the standard normal distribution table. The standard normal distribution table gives the probability of a regularly distributed random variable Z, that is called Z score, whose mean is equivalent to 0 and the difference means standard deviation equals to 1 is not exactly equal to Z. So the normal distribution is a persistent. Persistent means what? Continuous. Persistence means indefatigable. Pertinacious, tenacious, continuous. So a persistent this normal distribution or this Gaussian distribution is a continuous, persistent probability distribution. It is a continuous probability distribution or persistent probability distribution. Persistent means continuous. It is also called Gaussian distribution. It is also known as Gaussian distribution. So it is pertinent for positive estimations of Z only. Only positive estimations we take. A standard normal distribution table is utilized to determine the region under the band f of Z to discover the probability of a specified range of distribution. So the normal distribution density function f of Z is called the bell curve. We will see it gives normal distribution table graph. It gives us a bell-shaped curve. It looks like a bell. So what does it mean? Is that on the off chance that you need to discover the probability of a value is not exactly or more than a fixed positive Z. That Z is called Z score. So whatever you find the value, it cannot exceed our Z score. So we can discover it by finding it on the table. This is known as area. Now let us see types of probability sampling. There are several different sampling methods. They can be used for probability sampling. Some common sampling methods for probability sampling include simple random sampling. This is the most basic method of probability sampling, where every member of the population has an equal chance of being selected for the sample. Now let us see systematic random sampling. This is a probability sampling method where the sample is selected using a systematic random approach. This method involves selecting a random starting point in the population and then selecting every kth member of the population. For example, checking every sixth piece produced by the machine to be included in the sample. For instance, if the population contains 1000 members and the sample size is 100, the researcher would select a random number between 1 and 10 and then select every 10th member of the population starting from that point. This method ensures that every member of the population has an equal chance of being selected for the sample and can be more efficient than simple random sampling. So, a standard normal distribution table presents a cumulative probability linked with a particular Z score. Now, using this table, we will learn how to see the Z score for a given number. For suppose we have to see for 0.9568, 95. Suppose we have to see for 0.956. Then on rows we have to see at 0.95. On columns we have to see at 0.006. On rows we have to see at 0.95. On columns we have to see at 0.006. Those two values, where do they match? That value will become Z score of 0.956. Like that, one by one we will come to see. Let us study this table. This table is also called a Z score table. Here, let us see properly. Here, Z value, how to see? See on on rows 0.00, 0.01, those are there. On columns, rows and columns, let us see there. Suppose we have to see the value for 0.03. Suppose we have to see at 3.03. Then on rows see at 3. It is suppose minus 3. We are checking the value for minus 3.03. Then what we have to see? We have to see row at minus 3.0. Row you have to see at minus 3.0, and you have to see column at minus 0.03. Means here you can see at 0.03. Then here at rows minus at 3.0, and at column 0.03. what value we are getting? This value 0.012. So z of minus 3.03 is equal to 0.0012. 0.0012. Like that, we have to see normal distribution table. We have to find values from normal distribution table like this. We have to see, and we have to keep these values, substitute values in our steps, in our sum, and simplify. We will find the answer. So this is the way to see the Z-score table. Now, see this normal distribution curve, it behaves like this as a bell-shaped curve. So under this bell-shaped curve, we will find some area. Diagrammatically, the probability of Z, not exactly A, it is being a phi of A. That area we denote it as phi of A. It is figured from the standard normal distribution table, is demonstrated like this. So, using this matter, let us find and let us do some very, very important sums, problems on normal distribution. Let us see first one. For some computers, the time period between charges of the battery is normally distributed with a mean of 50 hours and a standard deviation of 15 hours. Rohan, here by seeing the sum in previous also we have discussed so many times, while we are reading the sum, then only we have to pick up the important terminology, important points for the solution of our sum. Here what they are telling, for some computers, the time period between charges of the battery is normally distributed with a mean of 50 hours. So here what is mean? Mu is equal to 50 and the standard deviation SD, standard deviation sigma is equal to 15 hours 15. Means what? Here literally their meanings also we have to know. Here for charging, that mean is 50 hours means all these cell phones or whatever, all these computers, they are on an average they are charging in between up to 50 hours. Means one computer may charge up to 55 hours. Other computer may charge up to 54 hours. Other computer, some other fast computer may charge between 45 to 48 hours. Whatever it may be, on taking their average, it is coming 50 hours. It is called mean. So that mean is 50 hours. And what does a standard deviation represent here? It is 15 hours means from slowest to fastest charging computer, the time interval is, the difference is 15 hours. It is the literal meaning of standard deviation. Now, Rohan has one of these computers and needs to know the probability that the time period will be between 50 and 70 hours. Means what we have to find? We have to find the probability of charging lying between 50 and 70. Means what? We are, in our terminology, we have to find P of 50 less than X less than 70. Between 50 and 70 hours. Means we have to find probability of 50 less than X less than 70. This we have to find now. For that, let us analyze like this. Let X be the random variable that represents the time period. Given mean is equal to 50, standard deviation is equal to 15, and we have to find probability P of 50 less than x less than 70. So by using the transformation equation, we know first z value, z score we have to find. What is z here? Z is equal to x minus mu by sigma. So the matter whatever is there in terms of continuous random variable, we are converting, we are changing into z score. So how? By using this formula, z is equal to x minus mu by sigma. Now for x is equal to 50, what is z? Keep it in that. X minus mu, z is equal to x minus mu by sigma. X value 50 minus mu value 50 divided by sigma is 15. 0 by 15 is 0. So x is equal to 50 means in our z language z is equal to 0. So like that we are converting. For x is equal to 50 means here according to this sum z score is 0. Same like that for x is equal to 70, what is z score? 70 x minus mu by sigma means 70 minus 50 by 15. It is 1.33. So lying between 50 and 70 is same as lying between 0 and 1.33 in normal distribution z score. That is same. Here what we have to understand is the probability lying between 50 and 70 is same as probability lying between z score of 0 and 1.33. That's why this is converting, we are converting it as a P of 0 less than z less than 1.33. 50 changed into 0, x changed into z, 70 changed into 1.33 in our z language, z score. So here this is same as this. That random variable we have changed into normal distribution z score. Now it is easy for us. Upper limit minus lower limit. By seeing previously I told you how to see z score values of z from z score table. P of 1.33 is 0.9082 from the table minus P of 0.5. It is 0.4082. Means it is nearly 41%. If we want to tell it in a percentage, it is 41% or 40.82%. If we round it off, it comes 41%. So the probability that Rohan's computer has a time period between 50 and 70 hours is equal to 0.4082 or nearly 41%. Like that, here in normal distribution, all those sums we use same methodology, same technique. Whatever given matter, that matter we convert into normal distribution using this formula. Using this formula, z is equal to x minus mu by sigma. And see table values from table, z table, and substitute, and we will find the answer. Let us see one more sum. Very interesting sum. The speeds of cars are measured using a radar unit on a motorway. The speeds are normally distributed with a mean of 90 km per hour and a standard deviation of 10 km per hour. Always remember, mean means it is the average of those speeds. One car may have 89 kilometers per hour. Other car may have 90 kilometers per hour. Other car may have 91 kilometers per hour. Other car may have 92 kilometers per hour. On an average, they are going with a mean average of 90 kilometers per hour. That is called mean. Next, standard deviation means highest speed minus lowest speed. That difference gives you standard deviation. Here standard deviation of 10 kilometers per hour. So here mu is equal to 90. Standard deviation is equal to 10. What is the probability that a car selected at chance is moving at more than 100 kilometers per hour? Means P of x greater than 100 we need. Here let us analyze like this. Let the speed of cars is represented by a random variable x. X be the speed of cars. To find probability that x is higher than 100 means we have to find P of x greater than 100. The probability that x is higher than 100 means we have to find P of x greater than 100. So by using the transformation equation, we know z is equal to x minus mu by sigma z score. So convert all these matter into our z score. For x is equal to 100, what is the value of z? 100 minus 90 by 10. X minus our z formula. X minus mu by sigma. All are there. Substitute. So z is becoming 1. So according to this problem, x is equal to 100 means z is equal to 1 here. Next, now let us find x less than 90 means it is nothing but in our language p is p of z less than 1. So it means from the graph total area, it is a p of z less than 1 means what? Total area minus area to the left of z is equal to 1. See, if z is equal to 1, then what we have to do? The total area whatever surrounded by this, from that the area which is left to this z is equal to 1, that area you have to subtract. Then it will become p of z greater than 1. So p of z greater than 1 is equal to 1 minus p of z is equal to 1. See from the table, it is 0.8413. So its value is 0.1587. So we found the value p of z greater than 1. Means in the sum, the probability that a car selected at chance is moving at more than 100 kilometers per hour means in our language that x greater than 100 means z greater than 1 we have to find. So p of z greater than 1, how we found? Total area minus area to the left of z, we have to subtract from that. Then more than that will come. So it is from tables 0.1587 means nearly 16% or 15.87%, or if we round it up, it is 16%. What is 16%? Depict. It is the probability of the car selected at chance is moving at more than 100 kilometers per hour. Now let us see one more important sum. A radar unit is used to measure speeds of cars on a motorway. The speeds are normally distributed with a mean of 90 km per hour and a standard deviation of 10 km per hour. What is the probability that a car picked at random is traveling at more than 100 km per hour? It is same as we discussed here. Now let us see one more sum, very important one. Entry to a certain university is determined by a national test. The scores on this test are normally distributed with a mean of 500 and a standard deviation of 100. Tom wants to be admitted to this university and he knows that he must score better than at least 70% of the students who took the test. Tom takes the test and scores 585. Will he be admitted to this university? We have to discuss now, we have to judge now. Now let us see, let x be the random variable that represents the scores. Let x be the random variable that represents the scores. X is normally distributed with a mean of 500. So mean mu is equal to 500 and the standard deviation of 100. So the total area under the normal curve represents the total number of students who took the test. If we multiply the values of the areas under the curve by 100, we obtain percentages. So for x is equal to 585, first of all you find z value using the formula z is equal to x minus mu by sigma. So 585 minus 500 by sigma is 100. Its value is 0.85, means 85%. The proportion P of students who scored below 585 is given by P is equal to area to the left of Z is equal to 0.85. Means you have to find, its value at P of Z at 0.85. From tables it is 0.8023, means 80.23%. So Tom got more percent than 75%, 70%, but 70% at least 70%, but he got 80.23%. So he can be admitted to the university. Tom scored better than 80.23% of the students who took the test. See, actually he has to get better than 70% of the students, but his score is more than 80.23% of the students who took the test. So he can be admitted to the university. Like that we have to judge. Let us see the length of similar components produced by a company are approximated by a normal distribution model with a mean of 5 cm and a standard deviation of 0.02 cm. Here mean is equal to 5 cm, standard deviation is equal to 0.02 cm. If a component is chosen at random, what is the probability that the length of this component is between 4.98 and 5.02? Here what you have to do? You have to convert the 4.98 and 5.02 into our Z score. C tables G their Z scores, Z values from Z score table and substitute and find the value. Next B, what is the probability that the length of this component is between 4.96 and 5.04 centimeter? Same, convert them into Z score and find the values. Here, first one, what we have to find? Probability of 4.98 less than x less than 5.082. It is nothing but probability of -1 less than z less than 1. So, from where this -1 and +1 came? 4.98, you convert into z. It is -1. 5.02, you convert into z value. It is +1. So, in a x value, this is nothing but in our normal distribution, it is same as P of. So finding the value finding the probability of P of 4.98 less than x less than 5.02 is same as finding probability of -1 less than z less than 1. So from tables it is 0.6826. In percent, if you want, 68.26%. Same like that, probability of 4.96 less than x less than 5.04. It is nothing but, in our normal distribution, it is nothing but probability of -2 less than z less than 2. Its value from table 0.9544 means 95.44%. Now let us see this sum. The length of life of an instrument produced by a machine has a normal distribution with a mean of 12 months. So here mean is 12 months and standard deviation sigma is 2 months. Find the probability that an instrument produced by this machine will last. First question, less than 7 months. Second question, between 7 and 12 months. Means what we have to find? For question A, less than 7 months means P of x less than 7 we have to find. So, convert this into our Z score. Z is equal to x minus mu by sigma. All values are here only. Then it comes minus 2.5. So, is it or not? Let us see. Yeah. What is x value? 7. What is mu value? 12. By what is sigma? 2. It is minus 5 by 2. It is minus 2.5. That's why z is less than z value is 2.25. Z value is minus 2.25. Z value is minus 2.5. So, here meaning is probability of finding x less than 7 is same as probability of finding z less than minus 2.5. From table, its value is 0.0062. Same like that. What is the second question they are asking? Finding probability between 7 and 12 months. Means probability of finding 7 less than x less than 12 is same as probability of minus 2.5 less than z less than 0. From table, it is 0.4938. So in all these things, what we are doing, just whatever given matter is there, we are taking and we are efficiently converting into our Z score. After converting into Z score, we are keeping those values in our sum, converting and we are keeping those values in our sum, and we are seeing from Z score table and taking those values and simplifying, and finally we are getting answer. Now let us see one more sum. the time taken to assemble a car in a certain plant is a random variable having a normal distribution of 20 hours and a standard deviation of 2 hours. What is the probability that a car can be assembled at this plant in a period of time? Here, let us take the values. The time taken to assemble a car in a certain plant is a random variable having a normal distribution of 20 hours and a standard deviation of 2 hours. So, mu is equal to 20 and standard deviation sigma is equal to 2. Now they are asking what is the probability that a car can be assembled at this plant in a period of time. Then two questions are they are asking: less than 19.5 hours. Second question, between 20 and 22 hours they are asking. Means what we have to find? P of x less than 19.5 we have to find. Now if we convert into Z score. Z is equal to x minus mu by sigma. What is x? 19.5. What is mu? 20 by what is sigma? 2. This is minus 20 minus 19.4. It is nothing but minus 0.5 divided by 2. It is minus 0.25. So this is the standard procedure. Whatever that continuous random variable is given there, that we are changing, converting into Z score. Whenever we are converting into Z score means we have converted the entire sum into our normal distribution. Now that entire sum came to our normal distribution hand. So that values we are indirectly we are converting into our Z score, and from Z score table we find the values, substitute and find the values. So we have here less than 19 probability to find less than 19.5 hours means P of x less than 19.5. It is same as probability of finding Z less than minus 0.25. From tables it is, from Z score table its value is 0.4013. Same like that. Second question what they are asking, between 20 and 22 hours. Means we have to find probability of 20 less than x less than 22. So it is equal to probability of for 20 this z value will come 0. For 22 this z value will come 1. So it is the same as probability of 0 less than z less than 1. Its value is 0.3413. How this 0, 1 came by converting like this. Z will for x is equal to 20, z value will come 0. For x is equal to 22, z value will come 1. Substitute, we will find the value. Same like that. Let us see one more important sum. A large group of students took a test in physics and the final grades have a mean of 70, means mu is equal to 70. While reading the sum only, we have to write its raw material here, or whatever we need mathematical terms, that we have to keep it here. Standard deviation sigma is equal to 10. If we can approximate the distribution of these grades, by a normal distribution. What percent of the students scored higher than 80? Means P of x greater than 80 we have to find. After that x we change into z and we will follow. Next question what they are asking, should pass the test, means grades 60. P of x is equal to 60 means we change into z and we follow. Next, should fail the test, means they have to get less than 60, x less than 60, means we change into z and follow. Same like that, for x is equal to 80, for x is equal to 80, what is z here? X minus mu by sigma is our formula, is equal to x is 80, mu is 70 by sigma is 10. So 10 by 10 it is 1. So for x is equal to 80 is same as z is equal to 1. Like that, convert x values, convert them into z score values. Same like that, for x is equal to 60, z value will become minus 1. For x is equal to 60, z value will become minus 1. So, first question, let us answer first question. Scored higher than 80 means scored more than z is equal to 1. Scored more than z is greater than 1. So, area to the right higher than z is equal to 1 is equal to 0.1586. It is 15.87% scored more than 80. See, from this bell-shaped curve, suppose if it is z is equal to 1, see, right, for this right hand side we have to take more than, means from this side you have to take right hand side, less than means left hand side we have to take. So it is from the tables it is 15.87%. This is 15.87%. So more than, getting my score more than 80 means it is nearly 16% or 15.87%. Next, for x is equal to 60, pass mark, means z is equal to minus 1 in our normal distribution. So we have to take area to the right of z is equal to minus 1, that is equal to 0.8413. It is 84.13%. Should pass the test. Next, third question. Should fail the test, means they will get less than 60. Means from 100%, those who got more than 60, if it subtract, we will get less than 60. It is 100 minus 84.13%. It is 15.87% should fail the test. Like that, we can analyze. Now let us see one more interesting sum. The annual salaries of employees in a large company are approximately normally distributed with a mean of $50,000 and a standard deviation of $20,000. Here mu is $50,000, standard deviation is $20,000. Now they are asking, first question, what percent of people earn less than 40,000? Means x less than 40,000 we have to find. That 40,000 x value, we convert them into z value and we follow. Like that. Second question, what they are asking, what percent of people earn between 45,000 and 65,000? All these 45,000, 65,000 we convert into z value, and in those z in between them we find and subtract. What percent of people earn more than 70,000? Means x greater than 70,000. That 70,000 we convert into Z value and we follow. So for x is equal to 40,000, here for x is equal to 40,000, Z is equal to, what is our formula? X minus mu by sigma. What is x? 40,000. What is mu? 50,000. What is sigma? 20,000. It is minus 10,000 by 20,000. So it is minus 1 by 2. It is minus 0.5. So for same like that other values, same procedure. Like this we will convert. For x is equal to 40,000, Z value is minus 0.5. Now what we have to find? What percent of people earn less than 40,000 means less than minus 0.5 in our normal distribution. So area to the left less than of Z we have to take. So minus 0.5 is equal to here area to the left of Z is equal to minus 0.5 we have to take. It is 0.3085 means 30.85%. Those earn less than $40,000. So the percent of people earn less than $40,000 is 30.85%. Now come to question B. What percent of people earn between 45,000 and 65,000? Same using this Z score, you convert 45,000 and 65,000 and find the values in between them. For x is equal to 45,000, Z value will become minus 0.25, and for x is equal to 65,000, Z value will become 0.75. So area between 45,000 and 65,000 is nothing but area between minus 0.25 and 0.75 in our Z score. So it is equal to 37.2%. So the percent of people earn between $45,000 and $65,000 is 37.2. Now come to third question. What percent of people earn more than $70,000? Convert same like this, 70,000 into our Z score. Z value will become 1. So P of x greater than $70,000 means P of Z greater than 1 means the area to the right of Z is equal to 1. It is 0.1586 means 15.86%. Earn more than $70,000 means the percent of people earn more than $70,000 is 15.86%. Now let us see very important sum. If x is a normally distributed variable with mean mu is equal to 30 and standard deviation is equal to 4. Mu is equal to 30 given, standard deviation is equal to 4 given. Now they are asking P of x less than 40. The means that 40 you convert into Z score. P of x greater than 21, convert into Z score and do. P of 30 less than x 35, 30 and 35 you convert into Z and follow. So let us see, for x is equal to 40, Z value will become 2.5. Hence P of x less than 40 is equal to, it is nothing but P of Z less than 2.5 means area to the left of 2.5. From where does it get? From that z-score table and bell-shaped curve. We will see, we can find that area, that table and curve they will provide, they are allowed, and from that you have to see that and you have to do take that value as 0.9938. Now come to question B. P of x greater than 21. Same. For x is equal to 21, z value will become minus 2.25. So P of x greater than 21 means P of z greater than minus 2.25. So it is nothing but total area minus area to the left of 2.25. Why left we take? Minus is there. So left you take. If plus is there, right you take. Then it is 1 minus 0.0122. It is 0.9878. Now come to question 3. P of 30 less than x less than 35. Means for x is equal to 30, z value is 0. For x is equal to 35, z value is 1.25. So finding the value for P of x, P of 30 less than x less than 35 is nothing but finding the value between P of 0 less than z less than 1.25. Same procedure follow and we can find the answer. So as a part of recapitulation, what can we see here? Here all these things what we are doing in normal distribution. So it is a persistent, pertinent the normal distribution, pertinent probability distribution. So the normal distribution is a pertinent probability distribution, indefatigable probability distribution. It is also a tenacious probability distribution, and it is also a pertinacious random probability distribution. So it never ends. So for infinite values of binomial distribution, we will find this normal distribution. So in this normal distribution, if mean value is 0 and standard deviation is 1, then it is specially known as standard normal distribution. So for standard normal distribution, we have to, it is standardized as mu is equal to 0 and z is equal SD, sigma is equal to 1. What does it mean? That probability distribution centered at 0 and vibrates with sigma value. So that entire normal continuous probability distribution, that is a normal distribution, it is centered at 0 and it moves away and it takes a maximum range with the value of sigma, that is standard deviation value here. Like that, this normal distribution is a continuous probability distribution, and whatever sums are given in continuous random variable, just we have to convert them into our z score using the value z is equal to x minus mu by sigma, and we convert those values into z score, and we have to take the values of these z score from z score table, and those tables we have to substitute in our sum, and we have to simplify. Finally we will get the answer. So like that we can solve many sums, very interesting sums in normal distribution like this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.